Well, now that we've seen how to change a temperature and how much heat is required to change the temperature, let's do an example just to get our hands a little bit inside the physics and see what's going on, see how to use this equation. So let's say we go outside on a typical summer Texas day. We're living in Texas and we go outside and we take a soda out with us and we want to help cool it down. So say we have 17 ounces, a little bit short of a 20-ounce soda. When we open it, it starts off with initial temperature of 104 degrees because, well, it's Texas and Texas is hot in the summer. And these values are chosen, partially because that's actually what happens, but another thing is it's going to make the conversions a little bit easier. So first thing you'll notice is that we have 17 ounces. Well, we don't like ounces. Ounces are an empirical measurement, not SI measurement. And 104 degrees Fahrenheit, again, not a SI unit. We would like Celsius or Kelvin. Well, the question we ask is how much energy do we need to remove from this soda, from this guy? How much do we need to remove to change its temperature from 104 down to 50 degrees Fahrenheit? Well, as I said, first thing, let's convert everything to MKS units. So 17 ounces is 0.5 liters, about 0.5 liters, and 0.5 liters of soda is about 0.5 kilograms of soda. I'm using the conversion from a volume to a mass using the density of water. It's a pretty good approximation. Also, 104 degrees Fahrenheit is 40 degrees. It's another one of these wonderful little marks. If it's 40 degrees outside, it's hot. So 40 degrees Celsius or 313.15 Kelvin. 50 degrees Fahrenheit is 10 degrees Celsius or 283.15 Kelvin. And last but not least, we need the specific heat of soda. So soda's in its liquid phase. I'm going to just use the specific heat of water just to make our lives easier. So 4186 joules per kilogram degree Kelvin. So now we just apply our formula, and the formula we're going to use, again, the heat change is equal to the mass times the specific heat times the temperature change. So we substitute everything in. We have 5 kilograms, a specific heat of 4,186 joules per kilogram Kelvin, and we have a temperature change of 30 degrees Kelvin. And it should be noted that we're removing the temperature. So this temperature change is actually a negative value, which means our heat is going to be a negative value, which means we remove it from the system. But when it comes out to it, the heat that we need to remove is 62,790 joules. It's quite a bit of heat. Takes a while to get there, and it's going to eventually take a lot of ice cubes melting to get the temperature from 104 down to 50. So that's a lot of heat that we have to remove. But now you've seen a problem of how to figure out how much heat required to make a change of temperature.